Welcome to Module 1, Lesson 3. Today we're going to be incorporating the concept of exponents to powers of 10 and its place on the place value chart. I'm going to start here with 10, which is just one group of 10. If I take 100, I have 10 groups of 10. If I take 1,000, I have 10 groups of 100, or 10 times 10 times 10. And I'll stop at 10,000, which is 10 groups of 1,000, or 10 times 10 times 10 times 10. One observation we made today in class was that the number of zeros tells us how many tens go into that. I have 2 zeros, I have 2 tens. I have 3 zeros, I have 3 tens. I have 4 zeros, I have 4 tens. We also learned exponential form, and that was that the base of 10 in this case time is raised to an exponent, which tells you exactly how many tens I'm being multiplied together. So I have 10 to the first power, it's just 10. If I had 10 to the second power, 10 to the second power, that exponent 2 tells me I'm multiplying 10 times itself 2 times. I have 2 tens being multiplied together. The pattern continues. 10 to the third power tells me I'm multiplying 10 times itself 1, 2, 3 times. That's what that exponent to the third power is. And then finally 10 here would be 10 to the fourth power, because I have 4 tens being multiplied together. The other thing we observed was that that exponent actually tells you how many zeros you have in standard form. So 10 to the fourth power is going to be a 1 with 4 zeros, a 1 with 4 zeros. 10 to the third power is going to be a 1 with 3 zeros. You can follow that pattern and guess that 10 to the sixth power is 10 times 10 times 10 times 10 times 10 times 10, or a 1 with 1, 2, 3, 4, 5, 6 zeros, or a million. We took this to the next step with a problem such as 3 times 10 to the second power, and that is just equal to 3 times 10 to the second power is 100, or 300. There's two ways to look at this. The way I just showed you here, by changing the 10 squared to 100. The other way to look at it is that for the exponent tells you how many places you're moving your digits. So for instance, that is 10 times 10. I'm moving 2 places. So the exponent not only tells you how many zeros, it also tells you how many places you're moving on your place value chart. So if I were to quickly visualize a place value chart, my decimal point was right there, and I had my ones and my tens and my hundreds, and I started out with a 3, and I wanted to make it 3 times 10 to the second. I have to move over 1, 2 places, and I get 300. Taking it one more step here, I have 3 and 4 tenths times 10 to the third power. Remember, this is making it 10 times, 10 times. It's making it 10 times bigger 3 times, so 10, 100, 1,000 times bigger. So I could think of that as my 3 and 4 tenths times 1,000. Or I could just look at that exponent and say I need to move my digits 3 places to make them 1,000 times bigger. doing that, I'm going to end up with my 3 and my 4, and that is going to be making it 10 times bigger. There's 100 times bigger, and there's 1,000 times bigger. And there's where my decimal point ended up. Again, it appears that we're moving that decimal to the right 1, 2, 3 places. It's actually the digits moving to the left to make them larger. Division's no different. I have 7 1/10 divided by 10 to the second power. The exponent tells me I'm dividing by 10 and then by 10 again, so I have to move all my digits 2 places to the right to make them smaller. So if I have my 7 and my 1, moving this 1 place and then 2 places, I need a 0 there. And I'm going to get 0 and 71 thousandths. My exponent was 2, so I started here with my decimal point. I moved my digits 2 places to the right, ends up here, and that's my answer. They can ask you all sorts of questions. Like for instance, on their homework, they're going to ask you to write numbers such as 10,000 in exponential form, and that's again that's going to be 10 times 10 times 10 times 10, or 4 tens. The number of zeros tells you the exponent, so that's going to just be 10 to the 4th power. They could give it in other ways. They could say, oh, 100 times 100 is what in exponential form. That's going to be 10 to the power of, well, that's 10 times 10. There's those zeros tell you there's 2 tens. These tell you there's 2 more tens. So I'm going to end up with 10 to the 4th power once again. Your homework has something like this problem here below. They ask you to fill in the pattern. So as I'm going from 6,500,000 to 65,000, I had that's to the power of 5. So if I were to write that, that looks like 65 times 10 to the 5th power. And this is 65 times 10 to the 3rd power. So it looks to me like I'm dropping down two powers of 10, or getting 100 times smaller. So I'm going to guess here that I should have 650. And then if I wanted to see the pattern work, so my decimal started here and I went 2 places back to get this answer. Then my decimal went 2 places back to get this answer. 2 places back does in fact give me the 3rd or the 4th number, so that pattern is correct. Sometimes you're going to be asked to explain how you got an answer. So this is pretty typical. Explain how to find the answer to the following problem: 40 and 2500ths times 10 to the 4th power. And so that exponent again is going to tell you how many places the digits are going to shift, and since it's times 10 to the 4th and not divided, they're going to shift to the left to make them larger. The 4 tells you that the digits are going to shift 4 places to the left, making it 10,000 times larger. So I wrote here that the exponent tells you how many places to shift the digits. Since we are multiplying, the digits shift left to make the value of the digits larger. The exponent's 4, so the digits shift 4 places left. And doing so, I'm going to get an answer of 402,500, or 402,500. It's useful, even though it's not exactly correct, to think of that exponent, that decimal place, of moving the 4 places. So it started out here, 1, 2, 3, 4. Although we know the digits are actually doing the moving, not the decimal point. It's without the place value chart, it's useful to think of the decimal point as moving. And that's it for today's lesson.